Hello everyone! In this video recorded lesson, I will be discussing about finding the mean and the variance of the sampling distribution of the sample means. So first, let's define mean. Mean has the formula mu, which is equal to the summation of x over n, and it is the sum of numbers divided by how many numbers there are in the set of data, also known as the average. So, mean, it is the average of group scores. Ito yung average, kumbaga yung scores na nakuha nyo sa exam nyo kapag inad natin yon at i-divide sa kung ilan kayo lahat. Yun yung mean. And then variance, sigma square, which is equal to the summation of the quantity x minus mu squared over n. So the variance of a dataset measures the average square of the deviations. It is the sum of the probabilities that various outcomes will occur multiplied by the squared deviations from the average of the random variance. So deviation means the distances between the data and the mean. So since the variance is a squared quantity, it cannot be directly compared to the mean value of a data or of a data set. It is therefore more useful to have a quantity that is the square root of the variance, which is the standard deviation, which is sigma is equal to the square root of summation of the quantity of x minus mu squared over n. So standard deviation, it is the square root of the variance. It is a measure of variation based on measuring how far each data value is different from the mean. So it shows how much variation there is from the average mean. Ito ay yung kung gaano magkakalapit o magkakalayo ang mga scores or data. So let's have here an example. Two sections in senior high school STEM were given identical quizzes. STEM A had a mean score of 15.4 and standard deviation of 6.25, while STEM B had a mean score of 12.9 and standard deviation of 4.15. So the question is, which section scored better in average? So if your answer is STEM A, then you are correct. Since STEM A has higher score, which is 15.4, then we can say that STEM A scored better in average. Next is, which has more consistent scores? Now, if your answer is STEM B, then you are correct. Why STEM B? Because STEM B has a standard deviation that is less than STEM A. Therefore, most students in STEM B are performing around the same level compared to the students in STEM A. So, since STEM A has a higher standard deviation, then the scores are more spread out. While STEM B has a lower standard deviation, it means that the scores are less spread out from the mean. So, let's go to the next example. The set of data below are the hours spent per day by the selected students in watching K-drama. So there are 4, 5, 6, 8, and 10 hours. So suppose a sample of size 2 are taken from this population of 5 students. Solve for the mean and the variance of the sampling distribution of the sample means. First, we're going to solve for the population mean with the formula mu, which is equal to the summation of x equals n. And x are the row scores 4, 5, 6, 8, and 10. We add them all together, then divide it by the population size, which is 5. And it gives us 33 over 5, which is equal to 6.6. Therefore, the population mean of the hours spent per day in watching K-drama is 6.6. Now, let's compute for the mean of sampling distribution of the sample means using the formula mu sub x bar, which is equal to the summation of x bar times p of x bar. But before that, we need to use the combination formula in order to know the possible samples of size 2, then compute their individual means. So this is the formula for the combination. So the population size is equal to 5. So 5 factorial over the sample size is 2, which is 2 factorial. Then 5 minus 2, we have 3 factorial. So 5 factorial would be 5 times 4 times 3 times 2 times 1 over 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. And it gives us 120 over 12, which is equal to 10. Therefore, there are 10 possible samples. So these samples are 4, 5, 4, 6, 4, 8, 4, 10, 5, 6, 5, 8, 5, 10, 6, 8, 6, 10, and 8, 10. Now we're going to compute the mean of every sample. So 4 plus 5 divided by 2 is equal to 4.5. 4 plus 6 divided by 2 is 5. 4 plus 8 divided by 2 is 6. 4 plus 10 divided by 2 is 7. 5 plus 6 divided by 2 is 5.5. 5 plus 8 divided by 2 is 6.5. 5 plus 10 divided by 2 is 7.5. 6 plus 8 divided by 2 is 7. 6 plus 10 divided by 2 is 8. And 8 plus 10 divided by 2 is 9. So these are the sample means. Now that we have the sample means, we're going to construct a sampling distribution. So since our sample mean here 4.5 appear only once, so the frequency is 1. Same with 5, 6, 5.5, 6.5, 7.5, 8, and 9. So 7 appeared twice in the sample mean, so the frequency would be equal to 2. Now for the probability, since 4.5 has a frequency of 1, then the probability would be 1 over 10. Then the same goes with the other sample means except 7, since it has a frequency of 2, then the probability would be 2 over 10. Now that we have the value of x bar and p of x bar, we're going to multiply them. So 4.5 times 1 over 10, that's 0.45. And then 5 times 1 over 10, that's 0.5. And then 6 times 1 over 10 is 0.6. 7 times 2 over 10 is 1.4. 5.5 times 1 over 10 is 0.55. And then 6.5 times 1 over 10 is 0.65. 7.5 times 1 over 10 is 0.75. Then 8 times 1 over 10 is 0.8. And lastly, 9 times 1 over 10 is 0.9. Now, since the formula for the mean of sampling distribution of sample means is summation of x bar times p of x bar, so meaning to say, we're going to sum it all. Then the mean would be 0.45 plus 0.5 plus 0.6 plus 1.4 plus 0.55 plus 0.65 plus 0.75 plus 0.8 and plus 0.9. Then it would give us a total of 6.6. So what can you observe between the population mean and the mean of the sampling distribution of the sample means? The population mean and the mean of sampling distribution of the sample means are both equal to 6.6. So why are they equal? It is because the samples are part of the population. Next, we're going to solve for the variance and standard deviation of the population. Using the formula for the population variance, sigma squared, which is equal to the summation of the quantity of x minus mu squared over n. And for the standard deviation, sigma is equal to the square root of summation of the quantity of x minus mu squared over n. So let's solve first for the population variance. So these are the values of x. Since we're solving for the population variance, we're going to use the row scores. So x minus mu. Since our mu or the mean is 6.6, we're going to subtract it from the values of x. So 5 minus 6.6, that is equal to negative 1.6. Then 8 minus 6.6 is 1.4. 10 minus 6.6 is 3.4. 6 minus 6.6 is negative 0.6. And 4 minus 6.6 is negative 2.6. Now we're going to square the values of x minus the difference of x minus mu. So negative 1.6 squared, that would be equal to 2.56. And then 1.4 squared is 1.96. And then 3.4 squared is 11.56. Negative 0.6 squared is 0.36. And lastly, negative 2.6 squared is 6.76. So we're going to get the summation of x minus mu squared. So that would be 2.56 plus 1.96 plus 11.56 plus 0.36 plus 6.76 divided by the population size, which is 5. Then it would give us 23.2 divided by 5, which is equal to 4.64. So the population variance is 4.64. Now we're going to solve for the population standard deviation. Since the standard deviation is only the square root of the variance, then we can solve it by only squaring the final answer that we get from the population variance. So square root of 4.64, that would give us 2.15. So therefore, the population variance is 4.64 and the population standard deviation is 2.15. Now we're going to solve for the variance and standard deviation of the sampling distribution of the sample means. So kanina ang sinolve natin is the variance and standard deviation of the population. Now, we're going to solve for the variance and standard deviation of the sampling distribution of the sample means. And for the formula of the variance, it is equal to the summation of p of x times the quantity of x bar minus mu squared. Well, for the standard deviation, is the square root of the summation of p of x and the quantity of x bar minus mu squared. So let's solve first for the variance. So since we're going to solve for the variance of the sampling distribution of the sample means, we're going to use the sample means, which are 4.5, 5, 6, 7, 5.5, 6.5, 7.5, 8, and 9. Yung nakuha natin kanina. Then we're going to subtract the value of mu, or the value of our mean, which is 6.6. So 4.5 minus 6.6, that would be equal to negative 2.1. Then 5 minus 6.6, that is negative 1.6. Then 6 minus 6.6 is negative 0.6. Then 7 minus 6.6 is 0.4. 5.5 minus 6.6 is negative 1.1. 6.5 minus 6.6 is negative 0.1. 7.5 minus 6.6 is 0.9. Then 8 minus 6.6 is 1.4. 9 minus 6.6 is 2.4. Then we're going to square the values that we get from this column. So negative 2.1 squared, that would give us 4.41. Then negative 1.6 squared is 2.56. Negative 0.6 squared, that is 0.36. And then 0.4 squared is 0.16. Negative 1.1 squared is 1.21. Negative 0.1 squared is 0.01. And then 0.9 squared is 0.81. 1.4 squared is 1.96. And lastly, 2.4 squared is 5.76. So next, the P of x, nakuha na natin to kanina. So we have 1 over 10, except for this sample mean 7, which is 2 over 10. Now we're going to multiply the P of x bar to the values that we get from x bar minus mu squared. So 4.41 times 1 over 10, that is 0.441. Then 2.56 times 1 over 10, that is 0.256. And then 0.36 times 1 over 10, that is 0.036. 0.16 times 2 over 10, that is 0.032. And then 1.21 times 1 over 10, that is 0.121. 0.01 times 1 over 10, that is 0.001. Then 0.81 times 1 over 10 is 0.081. Then 1.96 times 1 over 10 is 0.196. And lastly, 5.76 times 1 over 10 is 0.576. So we're going to add all the values that we get in this column. So the variance is equal to 0.441 plus 0.256 plus 0.0036 plus 0.032 plus 0.121 plus 0.001 plus 0.081 plus 0.196 and 0.576. So if we sum it all, it will give us a value of 1.74. So since the variance is 1.74, then the standard deviation would be square root of 1.74, which is equal to 1.32. So that is the variance and standard deviation of the sampling distribution of the sample means of the hours spent per day by the selected students in watching K-drama. Therefore, the hours spent per day by the selected students in watching K-drama has a population mean and mean of sampling distribution of the sample mean that are both equal to 6.6. And it has a population variance equal to 4.64 and variance of sampling distribution of sample mean, which is equal to 1.74. And the standard deviation of the population is 2.15, while the standard deviation of the sampling distribution of the sample means is 1.32. Let's proceed to the next example. The following table gives the sum of the tutorial rate of 6 teachers in Central Luzon per month. Suppose that the random sample of size 4 are taken from this population of 6 teachers. Solve for the mean and the variance of the sampling distribution of the sample means. So the tutorial rate of the 6 teachers in 1,000 pesos are 8, 12, 16, 20, 24, and 28. So first, let's solve for the population mean. So for the summation of x, we have 8 plus 12 plus 16 plus 20 plus 24 plus 28 divided by the n, or the population size, which is 6. Then this will give us a total of 108 divided by 6, which is equal to 18. So therefore, the population mean of the tutorial weights of the selected teachers in Central Luzon is 18,000 pesos per month. So next, we're going to solve for the mean of sampling distribution of the sample means. But before that, we need to know first the number of the possible samples using the combination formula. So for the n factorial, that will be 6 factorial since the population size is equal to 6, and the n factorial, or the sample size, is 4, so that would be 4 factorial. Then 6 minus 4 is 2, so that would be 2 factorial. And 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. And 4 factorial is 4 times 3 times 2 times 1. And for 2 factorial, it will be 2 times 1. Then this will give us 720 divided by 48, which will be equal to 15. Therefore, the number of possible samples is equal to 15. So these samples are this one. These are the 15 possible samples. And to solve for the sample mean, we add them. 8 plus 12 plus 16 plus 20. Then we divide it by 4, which will give us 14. Then 8 plus 12 plus 16 plus 24 divided by 4, that would give us 15. So the same process ang ginawa natin dito para makuha yung mga sample mean nila. Next, we're going to construct a sampling distribution. So dito sa sample mean natin, the frequency for 14 is 1 since 14 appeared only once. And then 15 also have a frequency of 1 since 15 only appeared once. 16 has a frequency of 2 since it appeared twice. Also with 17, it appeared twice. 18 has a frequency of 3 since it appeared thrice. Then 19 and 20 has a frequency of 2 since they appeared twice in 2020. Then both 21 and 22 also have a frequency of 1 since they appeared only once. Then since 14 has a frequency of 1, then the probability is 1 over 15. The same goes with 15, 1 over 15. In 16, the frequency is 2, so the probability is 2 over 15. The same with 17, which is 2 over 15. 18 has a frequency of 3, so the probability is 3 over 15. 19 and 20 has a probability of 2, so they have both 19 and 20 both have frequency of 2, so they also have a probability 2 over 15. And both 21 and 22 has a frequency of 1, so the probability is 1 over 15. Now we're going to multiply the sample mean to the p of x, or the probability. So 14 times 1 over 15, that is 14 over 15. And 15 times 1 over 15 is 15 over 15, or 1. Then 16 times 2 over 15, that is 32 over 15. Then 17 times 2 over 15 is 34 over 15. 18 times 3 over 15 is 54. Is 54 over 15. Then 19 times 2 over 15 is 38 over 15. 20 times 2 over 15 is 40 over 15. 21 times 1 over 15 is 21 over 15, and 22 times 1 over 15 is 22 over 15. So for the sample mean, we get the summation of the x bar times p of x bar. So 14 over 15 plus 15 over 15 plus 32 over 15 plus 34 over 15 plus 54 over 15 plus 38 over 15 plus 40 over 15 plus 21 over 15 plus 22 over 15 would be equal to 270 over 15, which is equal to 18. So the mean of the sampling distribution of the sample means is equal to 18. The same with the mean of the population, which is also equal to 18. So next, we're going to solve for the population variance and population standard deviation. So let's start with the population variance. So since the value of the mean na nakuha natin is 18, we subtract it from the values of x. So 8 minus 18, 8 minus 18 that is equal to negative 10. Then 12 minus 18, that is negative 6. 16 minus 18 is negative 2. 20 minus 18 is 2. 24 minus 18 is positive 6. Then 24 minus 18 is 10. Now we're going to square yung mga nakuha natin dito. So negative 10 squared is 100. Negative 6 squared is 36. Negative 2 squared is 4. 2 squared is 4. 6 squared is 36. And 10 squared is 100. So for that, we're going to add all the values of x minus mu squared. So 100 plus 36 plus 4 plus 4 plus 36 plus 100 divided by the population size, which is 6. Then it gives us 280 divided by 6, which is equal to 46.67. Then for the population standard deviation, since we're going to get only the square root of the value that we get from the population variance, so that would be square root of 46.67, which is equal to 6.83. So the population variance is equal to 46.67 and the population standard deviation is 6.83. Next, we're going to solve for the variance and standard deviation of the sampling distribution of the sample means. Let's go first with the variance. So since yung nakuha nating mu or mean is 18, then we subtract it from the x bar. So 14 minus 18, that is negative 4. 15 minus 18 is negative 3, negative 2, negative 1, 0, 1, 2, 3, and 4. Then we're going to get the square. So negative 4 square is 16, negative 3 square is 9, negative 2 square is 4, negative 1 square is 1, 0 squared is 0, then 1, 4, 9, and 16. Next, we're going to multiply this to the probability. So 16 times 1 over 15 is 16 over 15. 9 times 1 over 15 is 9 over 15. Then 8 over 15. Next, 2 over 15. 0 over 15. 2 over 15. 8 over 15. 9 over 15. And lastly, 16 over 15. So for the variance, we can now solve for the variance by adding all of this. So 16 plus 15, 16 over 15 16 over 15 plus 9 over 15 plus 8 over 15 plus 2 over 15 plus 0 over 15 plus 2 over 15 plus 8 over 15 plus 9 over 15 and 16 over 15. It will give us a total of 70 over 15, which is equal to 4.67. Then for the standard deviation, we're going to get the square root of the answer that we get from the variance. So the standard deviation is equal to the square root of 4.67, which is equal to 2.16. So that is the standard deviation and the the variance and the standard deviation of the sampling distribution of the sample means. So therefore, the tutorial rate of 6 teachers in Central Luzon per month has a population mean and mean of sampling distribution of the sample mean, which is equal to 18. And it has a population variance equal to 46.67 and variance of sampling distribution of sample mean, which is equal to 4.67. And the standard deviation of the population is 6.83, and standard deviation of sampling distribution of sample mean is 2.16. Let's wrap up. So for the population mean, the formula that we use is the mu, which is equal to the summation of x over n, while for the mean of the sampling distribution of sample mean is the summation of x bar times p of x bar. For the population variance is the sigma squared, which is equal to the summation of x minus mu squared over n, while the variance of the sampling distribution of sample mean is s squared, which is equal to the summation of p of x bar times the quantity of x bar minus mu squared. And for the population standard deviation, we have the sigma, which is equal to the square root of the summation x minus mu squared over n. And the standard deviation of the sampling distribution of the sample mean is the square root of the summation of p of x bar times x bar minus mu squared. So I hope you learned something in this video recorded lesson. Have a great day ahead.